Of the very large concepts that I should have been working on over this time, this is probably the most neglected part. I I sincerely have been putting it off because there's so much to do. There were so many main ideas to get out there even before I started to do any math or any, equations or any of that stuff. Because it was so new, it was like I had to have some type of foundation before I started making a building. I had to make the foundation first. And I think I've finally gotten to the point to where I can use basic principles and then find out where the information we have fits in those, and I can start making a building out of it and tying more of the pieces together. I'm doing it a bit backwards this time. Usually I put the Victor paper up, make sure it's published, and then I talk about it. But this time around, I typed it up, printed it out, and I haven't even posted it to Victor yet. So, here we go. Tying gravitational work to energy transformations and other principles in the general theory. The abstract is as follows. Gravitational work is defined as the star doing work on itself as it collapses into a planet. Or if you want to use the word astron, that works as well. This work translates to various energy transformations due to gravitational potential energy, which is GPE for short, being converted to kinetic energy, and then to friction, heat, and electrical energy, and back to potential energy in different forms. Gravitational work, as defined in the general theory, is work done on a star due to it collapsing, crushing itself, as it loses mass and energy, as gravitational collapse is a mass energy loss phenomenon outlined in this paper. So gravitational collapse, or gravitational potential energy, is the amount of energy a star has because it's fucking huge, and it's squeezing itself over billions of years, losing matter and losing energy as it does so. And that long-term billion-year cycle of squeezing the shit out of itself will lead to different types of energy transformations. And I'll go ahead and, before I read this paper off, I just want to get you guys started to kind of look at stars in terms of energy transformative processes. So energy transformations are, this is a little cartoon thing here. You'll see there, you have chemical going to mechanical, you have radiant energy going to chemical, you have chemical going to mechanical, you have electrical going to, what's that word? Thermal. So yeah, you got your ice cream and goes to the bicycle rider as food. You have the energy of the sun, and photosynthesis, helping plants out so they can make their own food. And then you have chemical energy. The gasoline goes and explodes inside the pistons, creating work on the drive shaft. And then electrical energy to thermal as resistance in the wire for toasters. And it's best to look at stars as objects that can convert energy like that in various forms, because that's exactly what they do. It happens all over the place, from clouds moving across the ground making lightning to the sun heating up water and it becoming vapor and then falling back down as rain again. Energy transformations are happening all over the place. But with stars, when they're really, really young, not at Earth's ancient stages, there are a hell of a lot more energy transformations happening because there's more material to work with. It's more gaseous. It can move a lot easier. I mean, if you look at pictures of Jupiter from the Juno spacecraft, you can see that the atmosphere is just this wild mess of crazy. You can't tell me there's no types of energy transformations happening there. It's direct evidence for a whole hell of a lot of action. I assure you there are chemicals that are fueling mechanical motion in the storms that are decomposing and synthesizing. I can assure you that radiance of different types of electromagnetic energy from Jupiter's surface is causing chemical reactions happening. And the chemical reactions, I'm sure, are, mechanical again. And, I'm sure that there's a lot of friction, and that can cause a lot of electrical energy, fueling different types of thermochemical reactions. And it's so complex, and it's so big, that I can only really do it justice by being general with it at this moment. So without further ado, I have 8 inline steps here. I'll go ahead and read those out and explain them. Number 1, the star contracts and some material falls inwards faster than other material. That's easy. Number 2, inward falling of matter inside the star means the GPE is being converted to kinetic energy. Potential to kinetic energy. This is where the math can begin to get really, really, really heavy. So potential meaning it hasn't fallen yet, and kinetic meaning it's falling, so it's moving. Think of a rock being on the top of a skyscraper, and somebody it has a lot of potential energy, the rock does, because it's inside the Earth's gravitational field. If you push that rock off the top of the building, then the potential is converted to kinetic as it falls. And obviously that makes friction, the wind resistance on the surface of the rock, it makes friction on the surface of the rock. Not a whole lot of friction, but enough. Number 3, the kinetic energy is converted to heat due to friction and charge separation due to the clouds rubbing together, transferring charge, thus large amounts of electroactivity. So think about Earth's gravitational field. Now think about how much energy, potential energy, inside of Jupiter's very strong gravitational field could cause matter falling inwards. It would heat it up a whole shitload. Oh yeah. Imagine a rock being pulled down with a lot more force than Earth can do. Yeah, there's going to be a shitload of friction on that rock, and it's going to heat it up and disintegrate it. And all those chemicals are going to mix in with other chemicals, forming even more complex chemicals. Number 4, the electrical activity and heat fuel thermochemical and electrochemical reactions under various different pressures and temperatures. So the different pressures and temperatures inside the atmospheres of the evolving stars also changes. As well, you have to include the fact that mass is being lost and energy is being lost. So even if, given the same place of that GPE being converted to kinetic energy, it could change as the star evolves. As well, if it scoots closer to a hotter host, it would expand outwards and become more puffy, so that would change the internal temperatures and pressures as well. We're talking about a very complex thing here. Number 5, thus the collapsing star does work on itself, forming chemicals in increasing complexity as the star ages and evolves due to energy transformations on very large scales. So the chemicals become more and more complex as the star evolves. Number 6, the direct evidence of this occurring is in rocks, minerals, and all the naturally occurring fluids and gases, even life, found on the Earth in various complexity, from repeating crystalline structures to incredibly complex life forms. So if anybody says, well, we have no evidence of this happening, that the star gravitationally collapses and that energy is transferred to kinetic energy, then to heat and to thermochemical and electrochemical reactions, well, of course we have direct evidence of it. It's the very ground we walk on. It's the earth. It's the rocks and minerals. It's the gas we breathe. It's who we are, man. Everything that we know to be on the earth is a direct result of the earth evolving. Number 7, the amount of energy provided by the star collapsing on itself will diminish as outlined in this paper. I link it to the bottom. And number 8, the mass of the star will also decrease, thus leading to a lessening of the amount of gravitational work that can be done on itself, slowing the rate of energy transformations and internal new chemical production. So less and less chemicals are formed as the star loses mass and evolves, because there's less to work with. Plus the gravitational field is diminished, so it can't do as much energy transformation as it could when it was much younger. Like the sun is right now. Can you imagine how many how many chemicals being synthesized in the sun. It's insane. It's just this giant chemistry lab. It's gonna slow down as it gravitationally collapses. And a little bit of clarification for people. I don't believe that stars are formed via gravitational collapse. I think what was happened is that astronomers, they got too overzealous concerning the fact that, you know, they had gravity to work with in outer space, and they started applying it to everything. I don't think that's how they should have done things. I think that they had a really great tool in their toolbox, like a hammer, and then everything became a nail. So when you only have a hammer, everything looks like a nail, but you know, they needed to have a wrench, they needed to have sockets, they needed to have, you know, a miter saw, they needed to have other tools to work with, but instead they just used their hammer for everything, and now it's a complete mess. Gravitational collapse should only be applied to objects that have the mass and energy to lose, meaning a cloud of pebbles and dust can't do shit. You need to have something that's actually there to collapse on itself for gravitational collapse to actually occur. And that's the major difference I have with establishment astronomy. They want to collapse things everywhere, and it's just overly used, and I don't think that's a good way of doing things. Alright, you guys, I think I made this video long enough. I'll link this to the bottom once it comes up on Vixer. Alright, later.